Question 19. A triangle has a vertex of P, Q, and R. So if I just roughly sketch a triangle with a vertex P, Q, and R, let's just roughly, and just draw that. Right, it's a triangle. So let's call that P, Q, and R. And the question says, the coordinates are -3, 6, -6, that's the coordinate. For R is 5, -2, and Q is 1, 4. Now in this case, the midpoint of PQ is M. So that's a midpoint somewhere, and we're going to call that M. And midpoint of QR is N. So roughly, if I draw a straight line, hopefully, I'll try and connect to it. So that'll be N. And that's the midpoint. We need to prove that MN is parallel to PR. So we need to prove that that is parallel to that. Okay, in order to do that, we need to find the coordinates of M and N. So first thing is find the coordinates of M and N. And then number 2, we find the gradient of MN and PR. If the gradients are the same, then they're parallel. So to find the coordinates, what we need to do first is use this formula. So the formula is x2 plus x1 over 2. That's for x coordinate. And y coordinate will be y2 plus y1 over 2. Those are the midpoint for M and N. So let's do that for QP. So PQ, to find the midpoint, will be, right, X is X2. So let's call that X2, Y2, and X1, Y1. And let's call this, and between this and that as well, so we have to do the same. So, okay, x2 plus x1 will be -3 plus 1 over 2. That will become -2 over 2, which is -1. And for y will be 4 minus 6 over 2, and that will become -2 over 2, which is -1. So the M coordinate will be -1, -1. So we need to find the same for QR. So for QR, we need to find x2 minus x2 plus x1. So let's call that, let's call this one now x1, y1, x2, y2. So the midpoint will be 5 plus 1 over 2, comma, and the y will be -2 plus 4 over 2. So that will be 3, and this one will be 1. So the midpoint here will be 3 and 1. Because 6 over 2 is 3, 2 over 2 is 1. Right. Or let me actually make it clear so it's not confusing. So that'll be 6 over 2 and 2 over 2, and that'll be 3, 1. That's how I got it. Right. After that, we know the coordinates. Now we can find the, so let's draw a straight line, or actually draw a perfect straight line. Sorry. Okay, and just do that. Right, so now we need to find the gradient. To find the gradient of mn, we just need to use, gradient is x2, and let's try this again. X2, just try y2 minus y1 over x2 minus x1. So that's the formula we're using. So for mn, the gradient should be, now, so that'll be 1 minus 1 over 3 minus 1. So that will become 2 over 4, which is a half. So the gradient for that one is a half. And PR, to find the gradient of PR, we use the same formula, y2 minus y1 over x2 minus x1. So this time, so we got x2, so y2 is minus 2, minus 6, so y minus 2 minus 6 will be equal to with 5 minus 3, and that will be equal to 4 over 8, which is also a half. Since the gradients are the same, therefore they're parallel. Since gradient are the same, therefore mn is parallel to PR. Right, question 20. Question 20, we're given the angle. We're told to calculate the area of the shaded region. So, in order to do this question, because you got the sector of circle, so basically we have a kite actually. And the best thing to do is angle OAB is 90 degrees and angle OCB is also 90 degrees, because the line, when a tangential line touches a circle, a line tangential to a circle forms a right angle with the circle radius, and that right angle is 90 degrees. So this is 90 degrees and that is 90 degrees. Now, next thing we need to do is to find the angle. So if I just draw a line across there. Right, so what we need to do is to find the angle here. So we need to find the angle ABC. So the angle ABC will be, well, if this is 90, 90, and 120, the angle ABC will be equal to 60 degrees, because total angle in a parallelogram is, or in the kite is 360 degrees. So 120 plus 90, and take away from 360 would be 60 degrees. Therefore, angle BAC is also equal to angle BAC is also equal to 60 degrees. So meaning that this triangle here is an equilateral triangle. So that's an equilateral triangle. BAC is also equal to ACB. In that case, these are 60, 60, and that's 60. So the best thing to do is to find AC. If we can find AC, we can then find the rest of the side. So AC is equal to AO squared plus OC squared minus 2AO OC cos 120 degrees. So I'm using the cos rule here, cosine rule. Now, I know what OA is. OA is 10, so that will be equal to 10 squared plus 10 squared minus 2 times 10 times 10 times minus a half. Cos 120 is a half. So if I put in your calculator, just put cos 120 degrees, that's minus a half. Now, minus times minus is plus, so that will become 100 plus 100 plus, because minus times minus 2, minus a half times minus 2 is 1, and 10 times 10 is 100, so plus 100. So AC squared equals 300. And therefore AC equals square root of 300, which is root of 100 times root of 3. So AC equals 10 root 3. What that meant is if AC is 10 root 3, therefore BC and AB are also 10 root 3. If I draw a line through B to O, that's half a kite. That's half a kite. Now, I need to find the area of OAB, the half a kite. So area of OAB. We know the angle here is 90 degrees in the middle. So let me just draw it out. So that's the half a kite. This is 90 degrees. This side is 10 meters and this side is 10 root 3 meters. We just work it out. So if I call that B, and this is A, and that's O. Now, we know that AC is equal to AB and BC. So that's why AB is 10 root 3. So that equals to AB, which is equal to BC. Right, because it's an equilateral triangle. Now, what we need to do now is find the area of the kite. And the area of the kite is, using sine rule, a half AB sine C, which is a half 10 times 10 root 3 sine 90. Sine 90 is 1. So that will be basically a half 10 times 10 root 3, which is 50 root 3. So that area for a full kite, which is times 2, so the area of a kite will be two times 50 root 3, and that will become 100 root 3. I also need to find the area of the sector in order to find the shaded area. So the area of the sector is the angle of the sector divided by 360 degrees times pi r squared. And so the area of sector will be 120 over 360 times pi 10 squared. So, and that will be equal to, if you work this out on the calculator, that will give you 104.71975551 meters squared. Now the area of the kite, if you push down the calculator, that will be 173.2050808 meters squared. So the area of the shaded area will be area of kite minus area of sector. So that will be area of kite, which is 173.205 minus 104.719, and that will be equal to 68.5 meters squared. 21. There are 12 counters in a bag. There is an equal number of red counters, blue counters, and yellow counters in a bag. There are no other counters in the bag. 3 counters are taken at random from the bag. We need to work out the probability of taking 3 reds. Well, so because they're independent, so 4, they're dependent actually, because if you take them out, then you cannot replace it back. So 4 in 12 times, now you got 11 left. Number 3 in 11, now you got 10 left, times 2 in 10. So the probability will be, so we got 4 here, 1, 4 here, 3, and 3 cancel 3, and you got 1 cancel 2 in there, and 5. So we now have 1 over 5 times 11, 55, and that would be equal to 0.0118. 18. Let me just write that clearly. So that will be equal to 0.1818. So roughly, times it by 100, that's 18%. So that will be 18%. So 1 over 55. Next question is the 3 counters are now put back into the bag. Some more counters are now put into the bag. There is still an equal number of reds, blue counter and yellow counter in the bag. There are no counters of any other color in the bags. 3 counters are taken at random from the bags. Is it still less likely or equally likely or more likely that the 3 counter will be red? Okay, so to do that, we need to, let's assume that we've now got 15. And so we're taking 5 of 15. So let's say there are 5 equal of each. So that means 15. The total will be, to start with, 15. So 5 over 15, we've taken 1 out, and we're left with 4 to take out from 14 times 4 over 14 times 3 over 13. So let's work this out. So how many 5 in 5, 1, 5 in 15, 3, times, well, 2 in 4, that's 2, 2 in 7, that's 14, 7, times 3 over 13. Well, 3 cancel 3, yeah, so we're going to have left 1, 1 times 2 over 7 times 1 over 13, which will give us, well, 2 over 91, because 13 times 7 is 91. And so, and that in percent, in decimal is 0.02197. So that's roughly 22%. This is more likely when comparing probability. Question 22. We have fx given to us and g of x given to us as well. So we need to find a and b, and also we have g3, which g of 3 is 20, and the inverse of fx, 33, equals g of 1. So to find a constant a and b, we need to rewrite this. G of 1 is a plus b. We're given that. We also know that g of 3, which is equals to 20, equals 20. But g of 3 is also equal to 3a plus b. So I've just replaced the x with a, and that will be equal to 20. We got f of x equals 5x plus 3. So if I turn the f of x into y equals 5x plus 3, I need to make x the subject, so I go 5x equals y minus 3, x equals y minus 3 over 5. Now I need to replace x with inverse of f of x, which is, and I need to replace y with x. So x minus 3 over 5. So that's the inverse. And that inverse is equal to G1, and G1 is equal to A plus B. And I need to replace the X with 33. So F of 33 equals 33 minus 3 over 5 equals A plus B. And therefore, I have A plus B equals 30 over 5, which is 6. So A plus B equals 6. And I also have 3A plus B equals 20. So if I subtract one from each other, I will get 2A equals 14. Divide both sides by 2, A equals 14 over 2, which is 7. So A equals 7. Then I also know that A plus B equals, and also know that A plus B equals 6. So A plus B equals 6. Therefore, B equals 6 minus A, which is B equals 6 minus 7, which equals minus 1. So therefore, B equals minus 1. So my answer would be A equals 7 and B equals minus 1. Question 23. S is a geometric sequence. Geometric sequence. Write the terms. The first term is root x minus 1. Second term is 1. And the third term is root x plus 1. We're told to find the value of x. So in this case, we need to find a common ratio because it's a geometric sequence. So the common ratio is 1 over root x minus 1 or root x plus 1 over 1. So that's the common ratio. Now, in this case, the two common ratio has to be equal to each other. And so, therefore, we can write 1 over root x minus 1 is equal to root x plus 1 over 1. And if I then multiply out, so I'm going to get 1 equals root x minus 1 times root x plus 1. So I need to multiply each other out. Root x times root x, so I get x still equal to 1. And I have had times root x times 1, I get plus root x. If I do minus 1 times root x, I get minus root x. If I do minus 1 times 1, I get minus 1. Root x cancels root x because it's plus and minus, so I get 1 equals x minus 1. Therefore, x equals 1 plus 1, which is 2. So in this case, x equals 2. So the value of x is 2. Right. The B part. We need to show that the fifth term of s is 7 plus 5 root 2. Well, we know that the third term is root x plus 1, and the fifth term will be equal to third term times common ratio squared, and that would be, so that's what the fifth term would be, so that would be root x plus 1 times root x plus 1 squared, and that will become root x plus 1 cube. Now to expand this, to expand that, what we need to do is do a plus b cube, and the expansion of that is a cube plus 3a squared b plus 3ab squared plus b cube, where a is root x and b equals 1. So now I can do my expansion. My expansion comes from Pascal triangle and binomial expansion. So I can now do my expansion by basically replacing the a with its values. So I get root x cube plus 3 root x squared bracket 1 plus 3 root x bracket 1 squared plus 1 cube. So that would be root x cube is will be x root x plus 3 x plus 3 root x plus 1, and that will become, well, don't forget that x is 2, because x equals 2, so I'm going to have 2 root 2 plus 2 times 3, 6, plus 3 root 2 plus 1, and that will give me 7, 6 plus 1, plus 5 root 2. So that's the answer, 7 plus 5 root 2.